what we learned in our previous class about instructions. For another 1 or 2 weeks, we are going to learn only about instructions. And you have written now some instructions in labs. So you are now aware of some instructions, right? You know about some instruction because you have already used it in the lab. 2 labs are over now. That means these instructions are familiar to you. Okay? We have already discussed about types of instruction. We have already discussed about something called addressing modes. What is this addressing modes? I have informed you in my previous class. Addressing modes tells you how the data is called, how the data transfer is happening, whether data transfer is happening between memory to register or register to register, or there is a data transfer happening with an immediate data written in the instruction itself, right? All these things I told you, right? So all these 4 we have discussed in our previous class. Hope you remember this. Okay? So direct addressing mode, for example, move AX, 234H, this transfers or copies the data from the memory with the offset address 2340 into AX register. Now can you tell me what is the size of the data transferred to the microprocessor? Whether it is 16-bit or 8-bit, it is 16-bit. Suppose if this is AL instead of AX, then it will be 8-bit. Right? Now you can see this is a data transfer. The data is transferred from the memory to register. Moment I say the data is transferred from memory to register, that means it is transferred somewhere from some offset address. Memory means always you will have this segment address and the offset address associated with that. That segment, that offset address is mentioned here. Have you understood here? Okay. Now, see the last sentence here. There is register indirect address. Here I have written move AX, comma, within the square bracket BX. What is this actually? This is also memory transfer. Data is transferred from the memory. When I say data is transferred from the memory, it has an address. But here there is no address directly written. But where is the address? It is in the BX register. This is called indirect addressing mode. These are the ways we write the program. More about this can be learned using programming examples. Whenever I take programming examples, I will tell you how to use these addressing modes. Right? These are 4 are the not only addressing modes used. We have other addressing modes which is similar to this indirect addressing mode. Similar to indirect addressing mode. Previously, here you said your address is available in the BX register. Now next, here if you see, where is your address available? Where is your address available? Your address is available in 2 registers now. One is in the BX register, another one is in the SA register. So the sum of the BX register content and SA register content gives you the actual address. Okay, see here. The effective offset address is the sum of the BX and SA register content. Suppose your BX register content is 1000 hexadecimal data and SA register is pointing to, that is 0012, that means content of SA register is 0012. Then what is the effective address? Effective offset address from which the microprocessor will read the data from the memory to AX register. What is that? Addition of this. That is 1000 plus 0012, that is 1012. The same instruction will become equivalent to move AX, within the square bracket 1012. Understood this? Now, see the next one. Here, this is called register relative addressing. Register relative. That means the effective address for this instruction is nothing but within the square bracket bx plus 10. Bx plus 10. That's the effective address. Have understood this? Bx plus 10. See, this instruction is also equivalent to move ax comma within the square bracket bx plus 10. Instead of writing within the square bracket bx plus 10, we can also write 10 square bracket bx. The effective address is now the content of the bx register plus relative to that 10. For example, if bx content is 1000, the effective address is 1000 plus relative address. Relative address is 0010. So effective address is 1010. So it is going to fetch the data from the offset address 1010. Have you understood this now? Okay. Now, if you understood these two, the third one is something same to that. Third one is a combination of these two, where your effective address is bx plus si plus 10. That's why it is called base relative plus index. This is base plus index. Base plus index. This is relative. Okay. Now this one base, relative and index. Understood this? Base, relative and index. That means your effective address, offset address is content of bx register, content of si register plus a relative value 10. I'll take an example. Suppose your bx is 1000, si is 0012 and relatively it is 10. The effective address will be 1022. This instruction for this content is equivalent to move ax comma 1022. Understood this? Okay. All these are different way you bring in the data from memory to register, or you put the data from register to memory. All these examples, we are trying to read the data from the memory, right? That's not the only way we have. We can also put the data from register to memory. Instead of having move ax comma bx plus si, I can also have another statement, move in the square, move after move within the square bracket bx plus si comma ax. What that does? It will copy the content of ax register to memory with that address, with that offset address. Understood this? Okay. So last scaled index mode, addressing mode, we'll talk about it by taking one example. In the tutorial class, I will talk about scaled indexing addressing mode. Now, have you understood about this addressing mode? Addressing mode is nothing but how you bring the data from the memory. That's all. Okay. Now, the next topic which I am going to tell you is far very important. Concentrate here.
Earlier, whenever we wanted to fetch data from the memory, it was called addressing. So you said we can do it the other way. That would be called
addressing only. Whether to get the data from the memory, I need address. Whether to put the data into the memory, that also I need address. So everywhere I need the address. And these addressing modes tell you how you generate an address. It can be only in bx register. It can be in bx register and also si register. While generating address, I can use only one bx register alone. I can use bx and si register together. I can use bx and si register together along with some relative value. Right? These are the different ways of bringing in the data from the memory or putting data into the memory. Then you can ask me, sir, why this is required? Why I need to use two registers? Why I need to use the relative? All these can be explained by taking any one program as an example. Right? Specific situations in the programming question, we may have to use this type of addressing modes. which can be explained only through the programs. I will explain you when I do the programmings. Right? Now this topic, what I'm going to do now, is very important. Without having any distraction, try to listen to this. I want all of you to make it clear in the class itself. It is not difficult. It is not at all difficult. It's very easy, but provided you concentrate on what I am telling here. Right? Okay. Listen. All of you know that you're writing the program using assembly instructions. All of you know. All of you done this in your class, in your lab. Suppose if I say move AL comma BL, or same instruction which I just used now, move AL comma within the square bracket 1 2 3 4. Right? Okay. See, whenever square bracket comes in your instruction, that means that is something memory read or memory write happening there. Inside the square bracket, you mention the address directly, or mention the address through BX register, or mention the address through BX and SA register through various addressing modes. Okay. All these instructions, when it reaches the microprocessor, it will be converted into machine instructions. Converted into machine instruction. What is that machine instructions? I have told you earlier. What is the machine instructions? It is all 0, 1, 0, 0, 0 combination. Right? Now, what is the size of the machine instruction we are generating? For 8086 microprocessor, we are generating a machine instruction of 16-bit. This is the what you call it as machine instruction we are generating for a particular assembly instructions. Different assembly instructions will have different machine instructions. But what is that machine instruction format we are generating? Or we can say, how do you convert a how do you convert an assembly instruction to the machine instructions? Right? There is a method for that. There is a method. There is a format. Instead of method, I can say there is a format. Right? According to the format, we generate this. Listen carefully here. First thing, your machine instruction is 16-bit wide. Your machine instruction is 16-bit wide. Okay. Now, there are 2 bytes. 16-bit means 2 byte. This is byte 1, byte 2. Okay. 16-bit means you have this various bits. You have D0 to D15. These are most significant bits, least significant bits. Have you understood till this point? Right? Okay. Now, these are the bits which is going to be filled with this. There are 16 bits. Now, to convert your assembly instruction into this 16-bit combination, we have certain formats. We have certain format. According to this format, you have to fill this. Our work is to fill these 16 boxes with ones and zeros. That is what your machine instruction is. Okay. Now, how do I fill this? How do I fill each and every bits of this? According to this format. You have to remember this format. You have to remember this format. Let us check. How do we insert values into this? See, first one is going to be your opcode. The first, that means 6 most significant bit. What are the 6 most significant bit here? D15, D14, D13, D12, D11, D10 is corresponding to opcode. What is this opcode? Opcode is nothing but that 3-letter mnemonics which you use. You use opcode while writing program, right? Move, M-O-V is the opcode. Add is the opcode. Subtract is an opcode. Okay? Understood this? Add with carry is an opcode. All these are nothing but opcodes. That opcode which you have, okay, that opcode which you have, whatever opcode we are using in assembly instruction, we are going to represent it in this 6 bits, most significant 6 bits. That means every opcode is represented by 6 bits combination, right? Every opcode is represented by 6-bit combination, right? Okay, that means tell me, when you have 6-bit combination for opcode, how many opcode I can represent? Tell me. 2 to the power of 6. That means for this 8086 microprocessor, how many possibilities are there? How many opcodes I can design, I can generate? 2 to the power of 6. What is 2 to the power of 6? 64. You understood this, okay? Every opcode will have one combination of that's 6 bits. Now let us see it one by one. Yes, 64 opcodes possible. 64 opcodes I can have. That means I can have 64 instructions.
That is only in 8086.
8086. This is, we are talking about only 8086. And this is the format of 8086 microprocessor. Now, let us see. We will take an example of move instruction. Okay? See. Let us take move instruction. MOV. MOV is the move instruction. My opcode is now move. Right? Now, see here. 10010 is a unique opcode for this move instruction, right? Every move instruction we use in 8086 microprocessor, its corresponding 6-bit combination for representing it into the machine learning, machine instruction is 10010, right? In the textbook there is one appendix A. In that appendix A, the 6-bit combinations for all the instructions is given. Please have a look into that. Okay, add instruction will have different combination. Your subtract instruction will have different combination like this. But for move is this one. Understood this? So now, in the process of converting your assembly instruction to machine instruction, one small step is over. We have filled D15 to D10. We have filled D15 to D10. But still we have D bit, we have W bit, 2 bits corresponding to mode, and 3 bits corresponding to register, and 3 bits corresponding to register bar memory still pending. But we have done this till here. So have you understood now? Till here, have you understood? The first 6 bits corresponding to the opcode. Now, next bit will be D bit. Okay, what is this D bit? Listen carefully here. Hello, close your laptop. Next bit is D bit. Okay, what this D bit does? What this D bit does? See, D is equal to 0. See, it is only 1 bit, right? It can take either 0 or 1. Right? It's called direction bit. D is equal to 0 when data is going from the register. That is, direction is from the register. That means data is going from the register. Listen carefully here. This D bit is equal to 1, okay, when the data is going to the register. Have you understood this now? Right? Without giving example, we will never understand this. See here example. Now tell me, you have an instruction move 1234h, ax. Now whether data is going to the register or data is coming from the register, data is coming from the register. That means, what about your D bit? D bit is 0. Right? Now see here, another instruction, move AX, a memory location, offset address 1234. Can you tell me, what is the D bit for this? D bit for this will be equal to 1. This is the way you can put the D bit. Have you understood how to put the D bit? Right? Is it okay? Now, what is the next bit? Next bit is W. Next bit is W. Okay. Now, while putting D bit, you are taking either data going to the register or data coming from the register. Okay. Now you remember which register is that, right? You have to keep it in mind which register is that. Can you tell me which register here? Here it is AX register. Okay. Now see here, AX is how many bit register? 16 bit. That means data transfer is 16 bit, right? Suppose if I have, instead of AX, if I have AL in that, then there is a 8 bit transfer, right? That's what I am going to represent it in W. W says, right, if you are transferring a byte, 8 bit, a byte, your W will be equal to 0. If you are transferring a word or 2 byte or 16 bit, then W is going to be 1. Now tell me this instruction. Can you tell me W bit is 0 or 1 here? Why W bit is 0? Now I have one more instruction. 1. Have you understood how to put the W? D and W bit? Any doubts? Okay. Now once you complete D and W bit, immediately you have to insert REG bit, register bit. Immediately you have to do that. This mode bit and read bar memory bit, we will do it later, after this. Okay. Now how to fill this REG? It's a 3-bit value, right? It's a 3-bit value. From where this 3-bit value will come? This will come from a table, and that table you need not by heart. It will be given to you in the examination. Okay. These 3-bit value, that is your D5, D4, D3 will come from a table. Okay. Which is that table? This REG bit, this 3-bit value comes from a table as per the register used in the instruction. Right. Now, while writing D bit, you already know that the data is coming from the register going to the register, right? You already know. You know which register is that. Okay. Remember that register and look into this table. Look into this table. Okay. Now tell me which is the, for example, if I use this instruction, the top instruction, if I use this instruction, see here, AL or AX, okay, whether it is AL or AX. Now what is the 3-bit value I should put into your D5, D4 and D3? How we got it? You got it from the table. You got it from the table. Now this 0, 0, 0 will be inserted into D5, D4, D3. These are values given by the Intel company itself. The people who have designed this microprocessor, they only give this. Because this is the one which generates your machine instruction, right? That's where machine instruction are understood by the microprocessor. It is designed according to the microprocessor control unit. These are given. Understood this? Okay?
So will the opcode also be given in the exam?
Opcode, this also will be given. If it is open book test, it won't be given. It is there in the textbook. Right? You have to refer to the textbook. So have you understood about now? Now tell me how many bits, how many we are able to put opcode out of 16-bit generation of machine instruction. We have done with the opcode, right? We are done with the D. We are done with the W. We are also done with register. What is pending now? Mod and R by M. Listen carefully. This is also coming from a table. It's very easy. If you know how to see the table, you can easily do that. This mode bit and R by M is also coming from the table. Now see this instruction. In that instruction, we have seen that data is going to the register, right? We have indicated in D bit. And also which register we have indicated here. But we are not indicated from where it is coming. Whether the data is coming from the register or memory. In this case, data is coming from memory. Yes or no? Right. It is coming from the memory, right? Data is going to the register. It is coming from the memory. Right? While coming from the memory, what type of addressing mode use there? Whether we are going to use direct 16-bit address provided here, or it is address is in the BX register, or address is in SA register, we need to mention that. That is what we mention in R by M and mode bit. Now in this case, tell me from where the data is coming. It is coming from memory, right? And it is coming from a 16-bit address directly mentioned here. Yes or no? All of you know about it. Now how to indicate corresponding mode bit and R by M bit? Listen carefully. Your mode bit is 2-bit value, comes from the table as per the mode bits, and this R by M is a 3-bit value, comes from the table as per the register memory usage. Now see the table. See the table. In this table, please refer to this table. See here. In this table, you see where you have that 16-bit address. 16-bit address. Can you tell me? Where you have this only 16-bit address. D16. See here. In the instruction, we don't have anything like this, right? Do we have anything like this in the instruction? We have the directly 16-bit address. D16. See D16. D16 is 16-bit address. Right? The instruction we have is move AL comma within the square bracket 16-bit address. And this is what this 16-bit address. Now tell me, what is the corresponding mode bit? See, if you go to the top, you get corresponding mode bit, and if you go to the left, you get corresponding R by M bit. So for this, your mode bit is 00 and your R by M bit is 110. You got it? You got it? Now how to, you fix that. You fix that 00 here and 110 there. So mode bit also you have now inserted and R by M bit also you have inserted. Is it not you got all the bits? Is it not you got all the bits now? For an assembly instruction, move AL comma 1, 2, 3, 4 H. What is the corresponding machine instruction? This is the machine instruction. How do you represent this machine instruction? Can I every time read 100, 100, 100, 100, 100, 110? I represent it in the form of hexadecimal. Now how do you represent it in the form of hexadecimal? Make a group of 4. See, what is this? What is this value? 6. What is this value? 0. What is this value? What is this value? 8. 8A06 is the 16-bit machine instruction for this assembly instruction. Now it's not over. It's not over. See, in this instruction, the address part, the offset address has to be part of the instruction. The offset address, this 1, 2, 3, 4 has to be part of the instruction. we need to be associating with that along with the instruction, machine instruction. How to append it? Very simple. See here, you got 8A06, right? Now after 8A06, you put the lower byte of the address, direct address first, okay, and then you put the higher byte. Which are the higher byte here? You put the higher byte of the address. Now you get the complete machine instruction for move AL, 1 2 3 4 H. How we got it? Very simple. First 6 bits is going to be opcode. D bit is 1. Why D bit is 1 here? Because data is going to the register. Why W bit is 0 here? 8 bit. Immediately, why REG is 000? From the table, it is AL register. Now, what is the mode bit and R by M bit? You have to see the mode and R by M table for the direct 16 bit. Get the corresponding mode bit and the R by M. Done. You got your 16 bit 8A06. Now for this instruction, since you have to append the address along with the instruction, that's why we put the higher byte, lower byte first and the higher byte first. Now tell me, you have to tell me now, where does this instruction, machine instruction is stored in the memory?
Sir, if we are doing register indirect addressing,
then it will change.
then how will we have that one?
I will come to that, don't worry. I'll come to that. I'll take different example and tell you that. Okay? Now for this, have you understood now? Yes. Now tell me where it is stored, where your program is stored. It is stored in code segment, of course, stored in memory, right? It is stored in memory. It is stored in some code segment with some offset address, right? You are writing your program as move AL, within the bracket 1 2 3 4 H. But when it is stored in the memory, what is stored? What is stored? This is stored 8A06 3412. This is what stored in the memory. This is what understood by your microprocessor. This is called a machine instruction. This is called your assembly instruction. You are converting assembly instruction to machine instruction. This is what stored in the memory. Now see how it is stored in the memory. In a particular code segment, with a code segment, when I say it is stored in code segment, there is a code segment address associated with that, right? Now see, suppose code segment, let it be 412AH. Let the offset address be 000H. See how it is stored. This is your assembly instruction. This is your machine instruction. Just now we got. First 8A will be stored in offset address 0000. Next address 06 is stored. Next 34 is stored. Next 12 is stored. Now physically in the memory, how it is stored? In the physical memory, it is stored in 20-bit address only, right? When the microprocessor executes this instruction, this code segment address will be loaded to code segment register of the microprocessor. Now tell me, where this 000 offset address will be loaded into the microprocessor? Which register? What is the offset register for code segment? Instruction pointer. This will be loaded to instruction pointer. And what microprocessor will do? It will generate a 20-bit address and it will refer to the memory. See, this is what 20-bit address is. And here also you have the same data. See, these two data is not different. These two are same. Your actual memory is this one. When I am telling that data is stored in this 20-bit address, means I am telling the microprocessor that it is stored in so and so segment address and so offset. Microprocessor will generate the 20-bit address and it will fetch the instruction. See, this is what's stored in the memory. Understood this? Okay. Now, do we have a time? Okay, I'll take the attendance first. So have you understood this? We'll take different examples. Right? Okay, now he has asked one question. Okay, let us do it. Let us do that. Okay, suppose instead of this 1, 2, 3, 4, assume that you have BX. AX is not possible. BX. Indirect addressing. Okay. Now you yourself have to tell me what are the changes I have to do here. Okay, exactly. You are right. Okay, opcode will remain same, right? You write it yourself in your book. Opcode will remain same, 100010. Okay. D bit remains same. Is it okay? D bit will remain same because my instruction is move AL comma within the square bracket BX only. Why D bit remains same? Because data reading is 8 bit. Yes. My W remains same. Yes or no? You write it. W remains same. Okay. REG remains same. What is change is your mode bit and R by M bit. Let us see that in the table. I will go back to the table. I'll go back to the table. Now in the table you tell me where within the square bracket BX is there. Where is that? Where within the square bracket BX is there? See here. See here. 111. Your mode bit is 00 and your R by M bit is 111. Now tell me what is the machine instruction you get? 00111. So what is the changes you are going to get here? Tell me. Mode bit same, right? What is changing is 111. Now tell me, instead of 6, what you get here? What is 0111? 7. Right. Now what is the final 16-bit machine instruction? Instead of getting 8A06, you will get 8A07. Suppose if I change this, instead of 1, 2, 3, 4, if I put BX. Now, in this case, do I need to append anything? Any address? Not required. Suppose if I just put here square bracket and BX, okay, after getting 8A07, do I need to append anything? Not required. Address is not a part of the instruction. Your machine instruction is only now 8A077. Have you understood this? Okay? Okay. So